Hey everybody, I just want to take a minute to go through glucose transporter and the GLUT transporters within the cell. So let's go ahead and get kicked off with the transporters. Okay, so all the glucose transporters are called GLUT and then the individual numbers. So I came up with a little mnemonic to help us remember everything. So this is my friend here. This is GLUT. GLUT is actually a little sensitive because he's always in the shadow of his really popular cousin, GRUT. So don't confuse him with GRUT. So he likes to say, I am GLUT. GLUT is, since he's so sensitive, he always has to tell himself that he is number one. He has to believe it within his entire body and his heart and his soul and everywhere in his body that he is number one. This is why we have the GLUT number one transporter throughout our entire body. Okay? So we're just going to go from the top down. GLUT is a little bit strange. You know, over here we have a little normal brain, but for whatever reason, his brain is just shaped like a 3. It's just rather unfortunate. GLUT actually has a very similar heart to us. So our heart has 4 chambers, and so does his. GLUT has this really odd liver that has just this very large 2 branded on it. So that's where our GLUT2 transporters are going to be located. GLUT2 transporters are also located within the beta cells, and the way that I remembered it was 1, then 2, and your beta cells have GLUT2 transporters. Lastly, there's a discrepancy between the PowerPoint and the book. In the book, it says GLUT2 transporters are exclusively located in within the intestines. There's only GLUT2 transporters, but in his PowerPoint, he said within his intestines, there's also GLUT5 transporters. So maybe remember 2 and 5 are both located in the intestines. Okay. He makes a point about GLUT4 transporters. So remember, GLUT4, those are located in the heart, the fat, and the muscles, that they're sensitive to insulin. So the way I remembered it is your heart is sensitive to insulin because that's where all your emotions and stuff kind of feel like they're coming from. And then I wanted to go over the actual glucose transport for GLUT4. So over here, this is just the basic schematic that's shown in our textbook. Okay, so right here we have an insulin receptor. Take this off. So we have an insulin receptor, so we're going to have insulin come in and bind. So what happens after this? We have tyrosine residues on this receptor inside the cell. So this is the cytoplasm. These guys are going to undergo autophosphorylation. So these OH groups on the tyrosines are just going to turn into phosphate groups. Okay? So the insulin receptor has been phosphorylated via. Remember in the textbook, it says we have vesicles that contain our GLUT4 receptors. So after we have this phosphorylation occur, we're going to have AKT signaling, and that's all it says in the book is AKT. So I looked it up. This means activated tyrosine kinases. So as we see, these got activated via phosphorylation. This is going to cause this entire vesicle to migrate and merge with the cell membrane. Then, as you can imagine, after we have this merge, we're going to have a lot more transporters, GLUT4 transporters appear on the cell membrane. The last thing that I wanted to add was he said that we would see an increase in Vmax. So this may sound a little bit strange because Vmax, we believe, doesn't change unless you increase the temperature or we change the enzyme. So the best way to explain this is go back to the assumptions of Michaelis-Menten. Remember that number 1 is each enzyme only has one substrate, and then number 2 is that the substrate is going to be in excess. So we're going to have a lot of substrate when compared to the enzyme. So this is an assumption. So this is the implied assumption is that this does not change. So whenever you increase the number of enzymes that you have within the cell membrane, you would expect the Vmax to increase.